All right, so next we talk about central tendency. So when we talk about central tendency, we talk a set of averages, and the word average in common use, lexical use, it has a very straightforward meaning. But when we talk in statistics about averages, there are multiple kinds of averages. For example, we have mean as one form of average. Then we have median. Although median is different from a mean, the method of calculating median is a lot different from mean, but still it is another type of average. Then we have mod, and finally we have mid-range. And again, when we talk about mean, we have multiple means. For example, we can have arithmetic mean, we can have harmonic mean, also geometric mean, and we can have weighted average mean, weighted mean. Okay, so there are multiple types of means. Okay, let's go forward and look at the mean. Mean is denoted by mu when we talk about population. If you remember from previous lectures, we spoke about parameters and statistic. When we talk about population, we talk about parameters. And when we talk about samples, the characteristics that we try to calculate in a sample, they're called statistics. So here, the population parameter of an average is called mu, and mu is written like this, which is equal to summation, which is the total sum of something, sum of x, here x are the individual values in the data set, and divided by total number of values that can be denoted by n. Now we will use a capital N for population, okay, and we will use a small n for sample. And there is another difference, that when we calculate sample mean, we do not denote it with mu. We only denote population mean with mu. We denote the sample mean by x bar. Okay, what is the method of calculating mean? So as we have seen the formula, all we need to do is we need to add up or come up with the sum of all these values. And here the sum is 343. And we divide that with the number of values. So how many values we have here? We have 7 values. So after dividing it, we get the answer, which is called the arithmetic mean. Now there is one interesting thing that you need to note, that the individual data values, they don't have any unit written with them, but we are given the indication that these data values, they represent ages in the number of years, okay? So when we write down the average, we write the unit of that data value, okay? So this shows the central tendency in the age of these people. So this value, 49 years, basically tries to sum up all these values within a single value. And how does it do that? It tries to just aggregate the impact of all these values in the center, and that center lies at 49 years. Okay, it is just like a balancing rod. If you put something to balance, where the balancing rod would be in the very center of it. So that is the mean of a data set. Next is median. Now median is a little different. As we have seen, that mean actually takes all the values under consideration and we add them up. But that's not the case with the median. In median, we rearrange the data. We create a sorted list. Okay, this is a sort, and this is an ascending sort, which means the data values keep increasing, okay? And then we calculate the number of values. We look at the number of values, how many values are there. And it is a lot easier when the number of values fall as an odd number. Okay, like here, we have total 7 values. So median is the central value in a sorted list of data values. So here, since we have sorted these values, the central value is 53. You can see there are 3 values on the left of it and 3 values on the right of it. So this is how you calculate median. We don't add up any data values. We only rearrange them. We sort them out and we look for the central value. But there is one more interesting point, which is that when we have even number of values, so it is difficult to find out a single central value. So then what you do, for example, let me add another value here. So now I have 8 values, okay, 8 data entries are there. So what I need to do, I need to find out the couple of values that fall in the center of the data value. Again, we have 3 values on the right, 3 on the left, and 2 within the central range. So we add them up and we divide them by 2. That gives the average or the center of these 2 values. So we are trying to estimate the exact center of the data, all right? And this is like dividing your data set into 2 equal parts. So this is how we find median. The third one is mode. Mode is the most repetitive value. It is a value that is being repeated most of the time in the data set. Now, in this particular data set, you can see that 57 is the value that is being repeated. And it is repeated for only 2 times. So this is a unimodal data. Unimodal data is data. Unimodal data is a data where we have only one mod. So there is only one value that is being repeated. But if we have 2 values that are being repeated for the same number of times, then we call that data set bimodal. Okay, so in bimodal data, we have 2 values and that repeat themselves equal number of times. What if we have more than 2 values that get repeated in the data set and for exactly the same number of times? Then we will call that data as multimodal. Multimodal. So one more point here, which I would like to show you. Remember, we prepared histogram and it had adjacent bars, and the highest bar showed the class which has the highest frequency. So this is the model class. We call it model class. Why we call it model class? Because it has the highest frequency, all right? It has the highest number of repetitive values in it. So this is called model class. Again, the same concept as mode. All right, so there is one more point here at the end of it. An outlier is a data entry that is far removed from other entries in data set. For example, if I extend this histogram, and you will find one single value falling here, which is very far apart from the data, that would be called an outlier. Now, let's make a sense of all these values, that what is a mean, what is a median, what is a mod, and why we use all 3 of them, why they all are different from each other, and where each can be used. So consider this, that the data that we have in front of us, the values don't get changed, but when we calculate the mean, that is 46.5. When we calculate the median, it is 48.5. And when we calculate the mod, it is 57. Now we are talking about age. We can also talk about salaries. We can talk about any other variable. But mean actually takes all the values in the data set under consideration, because we have to add all the values. Remember, summation x over n. Now there's a problem. For example, if there are extreme values in the data, here you can see that people in their age, they range from 29 to 53. For example, if I add one more person of 80 years of age, and with the addition of these 80 years into this data set, the mean would go a lot higher than any other value. Okay, so extreme values can fluctuate your mean average. So if you find a lot of extreme values in your data set, it is good to use median. But if you see that there are not many outliers or extreme values, then mean is a good, you know, kind of measurement for average. And again, if you want to see that what is the most typical case, what is the most common case in our data set, then mod is the best average. So depending upon the context, mean, median, and mod, they all have their own advantages and disadvantages. All right. Next, a very important concept, especially for students, because they are very considerate about their GPAs and they want to calculate their semester GPA or their cumulative GPA, grade point average. So this concept is used for calculation of GPA, which is the weighted mean. And now you can see that formula for weighted mean is a little different. Here we have scores, X are the scores, and every score has a corresponding weight. So we multiply the score with that corresponding weight and we divide that with total weight. Okay, let's understand that with an example. So here is a student and the student has a grading policy where 50% of the grade is basically dedicated to tests, 30% is allocated to the final, the 30% is dedicated to homework and final is worth 20%. So in total, we have 100% weight. And the student receives 80 points on tests, 10 points on homework, and 85 points on final. So let's see how to calculate the weighted mean. So here we have made this table where we have actually considered the marks per test, homework, and final. The scores in the test were 80, and then in homework 100, and in final 85. So we multiply the scores with the weights. If you remember, the weights for score was 50%, and the weight for homework was 30%, and weight for final was 20%. And after multiplying these two values with each other, scores and their weights, we get these products. So we have to add these products up and we add them up and we get a total of 87. Okay. So there are 87 aggregate marks that the student has got out of these three different assessment things. So let's calculate the average now. The weighted mean would be equal to summation XW, which we have calculated here, divided by total weights. So as you can see that 87 are the numbers or marks that the student has acquired. In total, there are 100 weights. So 0.87 or 87% is the grade point for this student. Okay, so it has 87% marks. One more thing, this is not the way that you actually calculate GPA in universities, although the procedure is very similar, but the scores and weights are a little different. For example, if you remember, we have grade points. So if somebody has scored A, the grade point would be 4.00. If somebody has scored A minus, the grade point would be 3.67. And if somebody has scored B plus, the grade would be 3.33. And for B, it would be 3.00. Now let's consider that a student has, three subjects. Let's consider that the student is studying biostatistics, English, and then Park studies, right? And the grade points that the student has acquired in biostatistics, he was really good or she was really great, and she got 4.00. In English, she got 3.67, and then in Park studies, she got 3.00. And then we have to calculate the weights. And where do we get the weights? If you remember, for every subject in university, you have your credit hours, and they are the weights. For example, for the biostatistics, you have 3 credit hours, same for English, and 2 credit hours for Pakistan studies. You multiply them with each other, you find out the products, you get the products A, B, and C, you add them up, right? And after adding them up, you divide by the total number of credit hours. How many credit hours are there? 8. So when you divide this product by the total number of credit hours, you get the total number of credit hours you get your GPA, grade point average. This is how you calculate the grade point average, which is also a type of weighted mean. All right.